even if we just consider molecules containing carbon and hydrogen, there remain a variety of orbitals we can use to connect carbons to each other. We group them as alkanes, alkenes, alkynes, and arenes. But now, instead of using hydrogen, we can connect the carbon to a variety of other elements. When we do so, the possible molecules vastly increase, but we're still going to group them according to properties and reactivity. So, for example, a specific atom should be attached to another specific atom with a specific orbital, and this would be called a functional group if it had similar properties and similar reactivity. An example of this would be a hydroxyl group. Now, a hydroxyl group is an oxygen singly bonded to a hydrogen and also singly bonded to another atom. I'm not being very specific about what that other atom is. So let's look at a single example. If that other atom is a carbon, we could talk about a hydroxyl group, being the oxygen and the hydrogen, but we could also talk about an alcohol, where we're discussing the carbon, the oxygen, and the hydrogen. That carbon must only be attached to other carbons or hydrogens. Now we can be even more specific than that and say it could be a secondary carbon. Now that's where that central carbon is attached to two other carbons. If we take our alcohol, we could change from having a single bond between the carbon and the oxygen and now having a double bond. We would lose the hydrogen and we'd no longer have an alcohol. The carbon-oxygen double bond is called a carbonyl. And there are a variety of sorts of carbonyl depending on what the carbon is then attached to. If the carbon is attached to two other carbons, this is called a ketone. Now we also have a trivial name for this molecule, and that's acetone. But that's more for historical purposes. The names ketone and carbonyl are going to be used systematically to be able to name a molecule, and when you hear those terms, you immediately know what functional groups you're talking about. So it's a lot more useful than the term acetone. If you know what acetone is, that's great, you know what it all is. But if you don't, it doesn't tell you much information. When we look at more complex molecules, we can identify specific functional groups within that molecule. Here is the rather delicious vanillin. And again, if I say vanillin, if you happen to know the structure, you know the whole molecule. If you don't, you're in trouble. But let's break vanillin down into some interesting functional groups. The first one I want to look at is called an aldehyde. It's not all of the molecule, it's only part of the molecule, and it is a carbon doubly bonded to an oxygen, singly bonded to a hydrogen, and singly bonded to another carbon. The next functional group I'd like to draw your attention to is called an ether. An ether is an oxygen bonded singly to two carbons. I'd like you now to look at a phenol. We've talked about an alcohol, so this is a more specific case. A phenol is a hydrogen singly bonded to an oxygen, singly bonded to a carbon, everything the same as an alcohol so far. But that carbon is in a six-membered ring that is an arene. Which means, of course, we also have an arene functional group in vanillin. And so we might refer to any one of these functional groups when we're trying to specifically talk about a part of vanillin.